Dear followers, welcome again. We continue our course. We are talking about UML diagrams. In the previous video, we talked about UML class diagram and in general about the object-oriented approach. In this video, we will talk about use case diagram. As we specified before, there are many benefits of UML. It is system-oriented, so we can understand all the components in the system and the relationship between these components. It is standard, so everyone in the domain can understand it and can share it. It is graphical, so it is easy to understand. It is object-oriented programming, so we can find a lot of languages that can implement our design. We said before that there are many diagrams in UML. These diagrams allow us to show the system from different point of view, to have a complete understanding of the system. Usually we start with the use case diagram to make people understand the system. What is important in UML also that even if we have different type of diagrams, but in most of these diagrams we use similar annotation, similar symbols to represent these diagrams. In these videos, we use the system of a connected home as an example in the previous videos, and we take some examples of this connected home to represent the class diagram before. What is a connected home? We try to measure different parameters in a building. We use different types of sensors. We have a central unit at the level of each apartment or each house. All these devices connect to this central unit in order to send data, and the user can communicate with this central unit in order to understand what happened in the house. The user may be the inhabitant in the house, and it may be a researcher, and it may be the system of the city. The data may be used at the level of the individual house, and it could be gathered at the level of a neighborhood or a city in order to understand the global behavior of the city. What is a use case diagram? It is very simple. You can see a use case here. What is a use case? We have an actor in the left, and we have an oval in the right, and we have a line to connect them together. One use case, it is a function of the system from the user point of view. For this reason, we start with use case diagrams. We start to understand the system from outside, not from inside, from the external environment. Who is the actor? Actor is a role played by a person, a service, etc., which interacts with the studied system. Even if we take in most cases the symbol of a human to represent the actor, but it is not necessarily a human. When we talk about a human, we don't talk about a specific woman or man. We talk about a role that one person can play. It may be also non-human. Even if we use the symbol of a human, it may be a software, so it may be another part of the system that use this system, or an external system who use this system. Use case, it is a specific way of using a system image of an expected feature triggered in response to stimulation from an actor. So if we want something from the system, we use this use case. For example, I want to register in the university, so it is a trigger, and the university should react, should do something in response to my demand. A sensor may send a value to the central unit, and the system should react when it receives this value. The user can consult the data in his house, so when he opens the window to know what happened in his house, the system should react. This is an example. A resident in a home can consult a consumption. This is a use case, very simple use case to represent one aspect of our system. We can develop this use case. We can add comments. In all UML diagrams, you can add the comments in such way. It is a type of note. We can say, for example, with a dash line, we can have this form. We say, consult a consumption of water, of electricity. We can add also to the relation, we can add a comment, or the resident can consult the consumption using a tablet or a computer. We can add comment related to the resident. We can say he is the owner of the house, or he is the tenant. Who is the actor in a use case diagram? It is an idealization of a role played by an external user, a process or a thing, tangible or intangible, that interacts with a system. The actor may be a physical or non-physical entity. As we say, it may be a service, it may be a program. The program in our central unit in the connected home may be consulted by another program at the level of the city. In this case, our role, our actor, is not physical. Several users can have the same role. For example, different people in the house may have the same role as a client, as an actor. In our system, all the inhabitants in the house may play the role of a resident in this use case. The same natural person can play different roles with regards to the system. For example, in our system, we can have a role for a researcher who will consult the data, and in an inhabitant, a resident, who will consult the data. But in the same time, perhaps a researcher resides in a home, and the same person can consult the data as inhabitant and as a researcher. Everything that is outside the system and that interacts with the system is an actor. So if we analyze well our system, all the entities that interact with our system should be represented as actors. These diagrams. We have some additions. There are some relationship between the use cases themselves. For example, we have the relationship of use and extend. What is the relationship of use? If you know a little bit the programming languages, we have what we call function or procedure in a programming language. And a procedure can realize a task, and many times we put them in a library. Here we have similar thing. So we have a use case, but this use case may be called by different use cases. So it may part of these use cases. For example, if we have identification of a client, of a person, and we have a use case of the user that want to consult the consumption, so he should identify himself at the beginning. So consulting a value in the tablet in a connected home uses the identification. Also, when a researcher wants to consult something or to copy the data, he should identify himself. So the use case B, if it is identification, it may be used by different use cases, like consulting, like transmission of data to the city, like analyzing data, etc. The second type of relationship between use cases, it is extent. What is extent? We have usually some normal sequence in the executing of a use case, in the realization of a use case. With extend relationship between two use cases, we can augment the behavior of use case B by some exception, because there is usual execution, usual realization of the use case, and there is some exception. Perhaps I consult the data in a connected home, but I choose a parameter that does not exist. What will happen in this case? What happens if a sensor tries to send the data, but in the same time the central unit was occupied with another sensor? These are examples from the connected home that show the relationship between the use cases using use and extend. Consult consumption use case uses identification. Also, when I consult the consumption, if there is something abnormal, I will be warned. It is an extension. If you see, look at the direction of the arrow. We should pay attention that to represent this relationship, we should use a dashed arrow. Another relationship between use cases, but this relationship we can find it in another diagrams in UML. It is inheritance. We saw it in a class diagram. In a class diagram, we show that one class can inherit another class. For example, a meter inherits the properties of a sensor. Line. For example, we can consult a physical quantity. It is a general use case. And consult a humidity. It is also a use case, but it inherits the consulting of a physical quantity, a general physical quantity. The same thing for temperature. If there is some procedure to execute in the upper use case, these sub-use cases will use the same procedure. As we have said, a big use case may contain some use cases, small use cases, and these use cases may be used by another big use cases also, as when we talked about identification. Inclusions also allow a complex case to be broken down into simpler subcases. Be careful, this is not a functional decomposition. When we prepared the functional tree, we said that each operation, each function in a functional tree will be decomposed in different parts. But here we will not decompose the use case. The use case should be special use case, should be able to separate it from the first use case and should be able to be used by another use cases. It is not also the temporal sequence that precises the use relationship between use cases. Usually when we analyze a system, we start to discuss with people to understand what happened. We try to read some documentation, and use case, it is one of the first programs that we, and use case diagrams is one of the first document that we prepare in order to understand the system. And also it is the first diagram that the analyzer gives to the designer. It should be understandable by any user, non-computer scientist. That means when we prepare the use case diagram, we should discuss also with the people who work in the system. If we prepare a use case, if we analyze a university, for example, the analyzer should take the use case diagrams and he should discuss with the people, with the student, with the professors, with the administrator, to know if these use case diagrams are correct or not. So it should be understandable by all the users of the system. This is an example about the inheritance. For example, it is another type of inheritance here, because in the previous slides we show the inheritance between two use cases. Now we can see the inheritance between two actors. We can see, for example, that the resident can consult the consumption in the connected home, can consult the indoor quantity, and can adjust the heating, for example. The administrator inherits the resident. That means he can do all the use cases. He can use all the use cases of the resident. Furthermore, he can, in the previous slides, we saw the inheritance between two use cases. Here we can see the inheritance between two actors. We can see that a resident in a connected home can consult the consumption, can consult indoor quantity, and can adjust the heating, for example. The administrator inherits the resident. What does it mean? That means he can realize all the use cases that the resident does. Furthermore, we can see he can add a sensor in the system. What is the scenario of use case? Usually, as we said before, UML is graphic, and the graphic facilitates the communication between people, but we need the human language in order to define, to specify the details, the exceptions, to understand, to refine our understanding. So the scenario of a use case scenario, it is a document, it is not standardized. It is not like when we talk about the forms that we use in use cases or in class diagram, they are standard diagrams, they are standard symbols. But here the document is not standardized, so it may be different from one analyzer to another. This document can, the first is identification. It is related to the use case because usually we have a huge quantity of diagrams, a huge quantity of documents in the analysis, and we should specify the relationship between each document and each diagram. So the first part, it is related to the identification. The second part, it is the step that we execute usually in order to achieve what we want in the use case. It is not the details of what the system do, but it is the order, the general order of the execution. Usually in a use case scenario we have three parts. The first, it is the identification. identification is very important, because usually we have a huge quantity of diagrams with huge quantities of scenarios, and we should know which scenario corresponds to which use case. The second part, it is related to the general steps that we do to realize the use case. The third is the general conditions, the assumption, and the necessary questions. For example, if we have main scenario of the use case, if we have some exceptions, etc. This is one of the documents that we can use for a scenario. We can see here use case name, area. So if you analyze a university, we have what is the name of the use case. If there is a number, usually we have numbers where I identify with some code our use cases. The area, so we divided the university in many sectors. This is the sectors of analysis, for example, related to student. Who is the actor to this use case? It is the student. We have some description, a triggering event, what the student do in order to activate this use case. A trigger type, is it external or temporal? Because usually the system may do something regularly. It is an internal, but it's temporal, and it may be triggered by an external event, by an external actor. Also, we have the steps performed in the main path without exception. What we do, what students do, a precondition. So to realize this use case, usually we suppose that we are in some situation. To register, for example, we suppose that we already identify ourselves. Post conditions, what happened after when we finish this use case. Assumption, etc. A priority, we can add it, the risk of in this use case. As I said, this is as an example of the scenario. It is not a standard. We can modify some thing in this scenario. We can make our proper scenario to match with our needs. We will talk about the alternative flow in the scenarios. As when we talked about extend use case, we said that we have a normal use case and we have an extend use case. Here we have the normal using, the usual using of a use case, and we have the exception. An alternative flow must be designed in such a way that it knows how to fit into the full flow that it's extending. An alternate, a use case extend another use case. The arrow was from the extend use case was from the exception to the normal situation. Here it is the same. We will take an example, the basic flow. If we will consult a consumption of our values in a connected home, first step, the user identifies himself, then the user chooses the wanted network. Is he want to consult the electricity, the water, etc., etc. After that, the user specifies the period. He wants to consult the water between such month and such month. After that, the system displays the graph, etc. So it is the normal using. The alternative flow handle presence of many meters. If at 2 in consult consumption, so we will check the number 2. The user choose the wanted network. In this case, when we are choosing this network, if there is different meters for water, for example, or for electricity, you know, now we may have many electrical meter, one for lighting, another for heating water, a third for the heating in a room, etc. In this case, if we have many meters of the same network, if we have many meters for the same network, the system will show a message which meter. The user should choose the sector of the network in the home related to the wanted meter. It is an exception for the second step in the usual, in the main, in the basic scenario. And we see here, it is very important that it is the exception who precise where the exception occurs. But when we see the basic flow, we don't see the exception. It is very important, because when we want to analyze, when we want to design, we should concentrate at the first on the main flow. We should concentrate on the basic flow. After that, we can add exceptions.